All right, what we need to do first of all here is find the area that is inside the r equals 3 sine theta function, but outside the 1 plus r equals 1 plus sine theta function. So let me get those graphed here, and we'll do that. 3 sine theta and r equals 1 plus sine theta. And so we probably will need to do a little zoom in action here. And then let me square it up. Okay. All right, so yeah, it turns out r equals 3 sine theta. It's a nice little circle here. And then the 1 plus sine theta is the cardioid shape. Something like that. All right. It's on the inside of 3 sine theta, but on the outside of 1 plus sine theta. So we're talking about, sometimes you have to figure out what they're asking, but in this case, yeah, it's inside the circle and outside the cardioid, so that would be that. Okay? So how would I do, then, such a thing? Well, if you think about it here, I'm basically I'm going from here to here. Think about, this is the integral. I'm talking about the integrals, and integrals, they sweep out an area, so I'm sweeping out. If I go from along the 3 sine theta function, that is this area from right about here where they intersect all the way over there. And then what I'm going to do then to find the area that I've got shaded there is I'm going to take the integral of that's swept out of the 3 sine theta curve. Let's put it this way. We'll have to let's do this one. Okay, remembering that the area of a curve in polar form is, 1/2 r squared d theta. So if I take that area of that part and then subtract the area of the other one, it's 1/2 r squared d theta. Wouldn't that get me that particular area? Because that would take, take that circular area here, so that would take this area, and then I subtract off the area of that cardioid shape from right there to right there. Take out that area, which is that area in there. So if I take those and subtract them, right, I would get the area that's under consideration here. Okay? Now, the only other thing is, what about the limits of my integration? Well, that's where I need to know these points, right? And what do you see, what is true about those 2 points? Well, It's where the two graphs intersect. And so the two graphs intersect where they're equal, right? So I need to set 3 sine theta equal to 1 plus sine theta. And find those points of intersection. And that'll be my limits of integration. Well, this makes us call up some knowledge about solving a trig equation. Remember these? Subtract sine theta here. Have 2 sine theta equals 1. And divide by 2 and have sine theta equals a half. So what does theta equal? Well, in quadrant 1, sine of theta equals a half. That would be what angle? Pi over what angle gives me a sine of a half? Sine equal to a half. Pi over 6, isn't it? Pi over 6? Be pi over 6. And so that would be this one. That's quadrant 1. Now, I also need this one over here in quadrant 2. And so that would be pi minus pi over 6, which is pi over 6, right? And so those are my limits of course, there's many other solutions to that. You keep going 2 pi's and so forth. But those are the two I need because of where they're located. All right, so pi over 6 to pi over 6. For both of them. All right, so that puts me what? This one would be the integral. Would be 1/2 times 9 sine squared theta, d theta, and this would be a little more. Let's see, 1 plus sine theta, 1 plus sine theta times. That's going to be 1 plus sine theta. Sine theta would be 2 sine theta. And then sine times sine is sine squared. Theta. Theta. Now this is, well, we're back to a squared sine. So that's, again, the half angle. Sine squared theta is 1/2 minus a half cosine 2 theta. And of course, that's 9 halves. So that would be integral of 9 halves times 1/2 minus 1/2 cosine 2 theta. Used that one several times now. Here, well, 1/2 times 1 would be 1/2. 1/2 times 2 sine theta would be just sine theta. And then 1/2 sine squared theta d theta. All right, so let's see, that would be 9/4. Multiply that in, you got 9/4. Do the antiderivative 9/4 theta. Then we have 9/4. That'd be will be the integral of cosine. I'll go ahead and just say that's the integral of cosine 2 theta d theta. Minus the integral of 1/2 would be minus a half theta. Sine, the integral of that would be cosine. And then we've got another double angle, don't I? Sine squared is again 1/2 minus 1/2 cosine 2 theta. Where'd I get? I lost my room here. All right, let's squeeze it in. Minus a half theta plus cosine theta. And then this is integral of a half times a half minus a half cosine 2. Close enough. Okay. So yeah, that basically I'm going to have 2 of these cosine 2 theta, the antiderivative there. That's just u substitution. U is 2 theta, so du is 2 d theta. So du over 2 is d theta. So I wind up with 9/4 theta minus 9/4 cosine of u. It's just sine of u, but u is 2 theta. Then I have du over 2, so I need another half there, don't I? So this integral winds up being that. So, is that okay? Now, I put them in parentheses there, but just so you know that, yeah, you've got to change all these signs. So it'll be 1/2 theta minus cosine theta. That'll be a 1/4. The antiderivative will be positive 1/4 theta, but it's going to change signs. And then we'll have a minus, so that'd be a plus 1/4. And then, again, with the u equals 2 theta, going to need another half, and doing the integral of cosine of u du over 2. So that's going to be a half of sine of u again, which is going to be 2 theta. And then I need to integrate that from my little integrals one. Make myself a note here. Okay. Can't go further than that. So I've got to do that from, what was it, 5 pi over 6? 5 pi over 6? Yeah. Looking at my notes, there was probably some we could have combined, and because I do have some. Well, I've got a half theta, a minus a half, and a positive 9/4. So it could be 9/8 sine of 2 theta and 1/8 sine of 2 theta. So, then I've got a quarter. So there's some things I could combine there. Matter of fact, I think I will, since I've got so many to plug in. All right, so let's see. 9/4 theta minus a half theta minus a 4 theta. What is that going to give me? Well, that's going to give me 8 pi over 4 minus 6 pi over 4 theta, 3/2 theta. I think if we combine all these, I get 3/2 theta. And then that's 9/8 sine 2 theta, and that's 1/8 sine 2 theta, but it's minus 9/8 plus 1/8. That's minus 7/8. Did I do that right? Not according to my paper here. Should just be a minus. All right, let's see what I do. 9/4. Where did I get that half? Oh, from that, okay. 9/8. Okay. That's 9/2 sine squared and 1/2 sine squared. That would be 4 minus positive. Something's not looking. I'm thinking this should just be minus sine of 2 theta. Oh, there you go. Yeah. It was right all along. Okay. There we go. Negative 9/8 plus 1. It's negative 8/8. I was right all along. Which is negative 1. Thank you. And then minus cosine. All right. Now I'm happy. Minus cosine or plus cosine? I have minus. That is right, isn't it? Huh? Had it right all along. Yeah. All right. The only thing concerning me is that minus cosine. I've got on my paper a plus cosine. Does that look okay, though? It is minus. I think it should be. Oh, yeah, that's what it is. Antiderivative of sine is minus cosine. That is minus make a plus cosine. All right. So I'm glad I have my paper there. All right, so now we plug into this. So we plug in your 5 pi over 6. So it'll be 3 halves times 5 pi over 6. Minus sine of 2 times 5 pi over 6. Plus cosine of 5 pi over 6. And then plug in the pi over 6. So it'll be 3 halves times pi over 6. Minus sine of 2 times pi over 6. Plus the cosine of pi over 6. All right. Let's see. That cancels. So that's going to be 5/4 pi. Where am I going to get this? Try it right here. Okay, so that's 5/4 pi. That's going to be what? Pi over 3. Sine of 5 pi over 3. Cosine of 5 pi over 6. I'll just do those all together here. 3, so that'll be pi over times pi over 4. That'll be sine of pi over 3. Minus make a plus, sine of pi over 3. And then minus, so it'll be minus cosine pi over 6. All right. Well, we've got 5 pi over 4 minus pi over 4. It's 4 pi over 4, which is pi. Minus 5 pi over 3. That's going to be 60 reference, so that's square root of 3 over 2. Once upon a time, yeah. Cosine of 5 pi over 6. Again, quadrant 2 here, and the cosine's negative, so that'll be a negative. Cosine of, that's 30 reference angle. And so cosine is also square root of 3 over 2, isn't it? All right, and then sine of pi over 3, so that's sine of 60, square root of 3 over 2. And then minus cosine of pi over 6, it's cosine of 30, which is square root of 3 over 2. All right, and so those cancel. For some reason I'm thinking they all should cancel. Let's check these. Sine 5 pi over 3, sine is the y, so that's a positive. I'm getting pi minus square root of 3 over 2, 2 square roots of 3 over 2, which is square roots of 3. We'll go with that. Okay. Okay, I think I see. Let's back up here. Go back to this one right here. 5 pi over 3, that is actually quadrant 3, isn't it? Which does make sine a negative. That's what it was. So you have negative and negative, which is a positive, so they do all cancel out. All right. I was thinking they should cancel. All right. That's all I got.